Hey everyone, welcome back to The Explainer. So let's just jump right into one of the absolute biggest headaches in AI development right now, hallucinations. You spend all this time building a beautifully complex retrieval augmented generation, or RAG system, and it still confidently gives your users a totally wrong answer, and it does it with total authority, right? Why does that happen? Well, today we are mastering chunking. It is literally the secret weapon to stopping AI hallucinations dead in their tracks.
So why exactly do these systems hallucinate? A lot of times, we just blame the large language model. We think, the AI just got confused. But honestly, the truth usually comes down to poor data retrieval. Think about it. If you feed the AI garbage context, it's going to give you a garbage answer. The way you prepare and break down your data before it ever even reaches the LLM, that dictates exactly what the AI can actually retrieve.
Okay, so here's our roadmap for solving this hallucination problem together today. We're going to start with the engine of RAG, then look at why chunking matters. After that, we'll break down the core chunking strategies, talk about balancing the trade-offs, and finally wrap up with some production best practices. Let's get moving.
Starting off with Section 1, the engine of RAG. Let's quickly establish our mental model for how we actually process all this knowledge.
Think of chunking, kind of like cutting a book into searchable pieces. If RAG is the engine of your AI, chunking is how you prepare the fuel. You're taking massive, dense documents and breaking them down so the system can actually find what it needs. If you cut the book into pieces that are way too small, you just get these meaningless fragments of sentences. But if the pieces are too big, it's like handing the AI an entire chapter when it really just needed a single fact. It's way too hard to search. So our goal here is finding that perfect balance, just the right amount of context.
Let's look at how this builds into your actual architecture, especially if you're a junior dev just joining a team and trying to map the data flow. You start by splitting a document into chunks. You turn those into embeddings, and then you store them in a vector database. Simple enough. Then when a user makes a query, the system embeds that query, searches the vector DB that has your chunked data, retrieves the relevant context, re-ranks it, and only then feeds it to the LLM to generate an answer. The absolutely crucial point here is that your retrieval quality depends entirely on how those chunks were created at the very beginning of the flow.
Moving right along to Section 2, why chunking matters. Let's look at the stark contrast between doing this perfectly right and doing it completely wrong.
Let's look at a really practical example. Imagine a user runs a query asking to explain tax benefits for freelancers. With bad chunking, the system arbitrarily splits the text right in the middle of a sentence. Because of that, critical context is missing, totally irrelevant data gets retrieved, and your answer quality just plummets. The AI basically has to hallucinate to fill in the gaps. But on the flip side, with good chunking, we have a full paragraph about tax rules preserved within a clean semantic boundary. This guarantees high relevance, better recall, and significantly lower hallucination rates, simply because the LLM gets a complete thought to work with.
Which brings us to Section 3, Core Chunking Strategies. Now we need to look at the actual tools we have available to slice up this data.
Here's a high-level summary of the 4 main weapons you have in your architectural arsenal. We've got fixed, semantic, overlapping, and adaptive chunking. Each of these strategies has some distinct pros and cons depending on your current skill level, how uniform your data is, and of course your specific use case. Let's break these down one by one so you know exactly when to use them.
First up is fixed chunking. This is by far the simplest method. You're just splitting your text by a strict predetermined size, say exactly 500 tokens. You might literally just write a basic function that slices the text right at that limit. The pros? Well, it's incredibly simple and blazing fast. The cons, though? It ruthlessly breaks context. It'll chop sentences in half like a blunt axe, completely ignoring the meaning of the words. You really only want to reach for fixed chunking when you're dealing with massive amounts of highly uniform data, where raw processing speed is way more critical than absolute precision.
Next, we have semantic chunking, and honestly, this is generally considered the gold standard for pure quality. Instead of using arbitrary token limits, you split the data based on its actual meaning. You separate it by paragraphs, logical sections, or specific topics. The brilliant thing about this approach is that it preserves context and ensures really high relevance for the LLM. The trade-off, though, is that it requires natural language processing, or NLP, to actually find those logical boundaries, which means it's going to take up more compute power.
Then there is overlapping chunking. The crucial concept here is continuity. Imagine chunk 1 covers tokens 0 to 500, and chunk 2 covers tokens 400 to 900. They share a 100 token overlap. So why do we do this? Well, it drastically reduces context loss at the boundaries of your chunks, which gives you much better recall. It's absolutely critical for really long documents like complex legal contracts or dense technical text. The catch, as you might have guessed, is that you're storing duplicate info, which means higher storage costs in your vector database.
Finally, we've got adaptive chunking. This is a much more advanced technique. Here, the chunk size is actually dynamic based on the content you're processing. Short, simple sections automatically get small chunks, while dense, complex sections get larger chunks. It is incredibly context-aware and highly optimized for retrieval. But yeah, it's definitely quite complex to implement and maintain in a live production environment.
All right, Section 4, Balancing the Trade-offs. Let's talk about the architectural decisions and those push and pull factors you have to weigh when you're building. As an AI developer, your job is basically constantly optimizing trade-offs. Think about how chunk size directly impacts your retrieval quality. If you use small chunks, you get really high precision, meaning the search matches exactly the specific keywords you want. But you get low context, so the LLM might not have the full picture to actually explain the why. Conversely, if you use large chunks, you get high context, giving the LLM plenty of background, but lower precision. That means you might accidentally pull in a lot of irrelevant noise that dilutes the final answer.
So, you're probably wondering, what's the magic number? Well, while it's always going to depend on your specific use case, the generally accepted sweet spot is right around here, between 200 and 800 tokens. This range usually provides enough precision to find exactly what the user is asking for, while still keeping enough of that surrounding context to give the LLM the solid material it needs to avoid making things up.
And this naturally builds into our next set of trade-offs. You really have to balance overlap and retrieval volume. On the one hand, more chunk overlap gives you better recall, meaning you're way less likely to miss an answer that spans across two different chunks. But like we said, that comes at a higher storage cost. On the other hand, if you configure your system to retrieve a higher volume of chunks per query, you get better overall coverage of the topic, but you introduce way more noise into the LLM's prompt window. And if you feed it too much noise, you literally trigger the exact hallucinations we're trying to prevent in the first place.
Finally, Section 5, Production Best Practices. Let's run through a quick, rapid-fire checklist before you go out and build.
Okay, so if you're taking notes, here's your definitive checklist to make sure your system is actually production ready. Number 1, use hybrid chunking. Combine those semantic boundaries with overlapping tokens to get the absolute best of both worlds. Number 2, metadata tagging. Always store the title, section, and source right alongside your chunk text. This dramatically improves your pre-filtering capabilities. Number 3, chunk indexing. Pre-compute your embeddings and store them efficiently. Number 4, context-aware retrieval. Ensure your system can seamlessly combine multiple chunks while maintaining a logical flow. And finally, number 5, evaluate. You need to continuously measure both your retrieval accuracy and the quality of your final answers.
Which brings us to our final thought for today. I want you to look at the data sitting in your vector database right now and ask yourself, is your data just cut up into pieces, or is it truly ready to be understood? Poor chunking is just blindly slicing up text. Great chunking, though, that is architecting knowledge. Go experiment with these strategies, tweak your overlaps, and watch those AI hallucinations just disappear. Thanks so much for joining me on this explainer, and happy building!